energizing the poles in sequence, but we have to do that 4 times. You can imagine we bolt that on 4 times to actually get the rotor to go round and back to starting position again. So we have to be mindful of that. But if you actually look at the torque, if we switch the current as a constant current, bring it up to, in this case I think it's 2 amps you guys need. If you have 2 amps going in, so remember the transistors have to do that. And will you get a rise temperature that sharp? Don't think so, but it's a theoretical concept at the moment. If you have applied constant current, switch it off and then energize B, switch it off and then energize C, and then repeat. So when you de-energize C, you energize A, this is what you do here. That will give you 90 degrees. And if you actually were to physically measure the torque as applied to the motor, you will not get constant torque, you actually get a ripple. So you can see where A is energized, then B takes over, then C. So if you actually measure the torque on the shaft, what you will get will be a ripple. And in which case that might actually be quite severe depending on what the torque switching is taking place. So quite frequently, the power or the control electronics actually needs to shape that, and so does the power electronics if you take this to a commercial unit with high performance. But for our simple mini project, that's not a consideration that we have. So again, thinking about what we're doing here, electrical angle being only 90 degrees physically, then we require 4 sequences per revolution. Now, I've put down 120 RPM here. This is simply giving an indication of what the switching speed needs to be. Now, the reason why I put 120 RPM is because over the last 5 years, we've had a number of very good designs which have reached that speed. So it's reasonable for me to actually look at them again. However, we will only be offering a speed of 20 RPM. That's the spec. No more. Okay, so the reason for that is because although we will ramp the speed up very slowly to give you 20 RPM, we cannot be certain that either one of your own designs can reach that speed. So to make sure we have a common denominator, the maximum speed that we will be going to is 20 RPM or slightly faster, so you meet the specifications for your coursework. Okay? If you want a faster speed, then you have to negotiate separately. Okay, so that's the first specification rule. 20 RPM sufficient for you to meet the specification for the course. If you want to go faster than that, you need to talk to us. But to give you an indication, if 120 RPM, that equals a half a second per revolution, because 1.5 seconds. 20 RPM is slow. Really slow. 20 RPM, well, you could probably have a nap between revolutions, quite frankly. But the point is not about speed, it's about control. So that means that we switch, that current is high for 42 milliseconds. 42 milliseconds on here, 42 milliseconds on here, 42 milliseconds on here. Repeat that 4 times and you get a revolution every half second. Okay. So that sort of gives, I hope, my students an idea of how fast we have to get this to work. It's actually quite slow, so it will not present a problem in terms of speed, but it will present a problem in the sense that we have to switch it that slowly, because if we don't, maybe the motor won't respond. Okay, what we're going to finish up with is basically a little talk about the I/O characteristics and what that means, and then we'll go back a couple of slides to talk about the waveform again, so we can have a discussion about what the consensus will be about the shape of the waveform. Okay, this is going to be applied rigorously, and certainly, from a point of view, if I was going to be a commercial company, this would be, again, any deviations from this won't be accommodated. So the reason why I warn you about that is because if we present you with a control circuit on the day, okay, and you have a completely different pinout, and you wire it completely wrong, that's your responsibility. That's yours. That's your concern. We won't change the wiring to accommodate you. So let's be certain about what that means. What I am suggesting is that we have 4 pins on each of the boards, one the board for control electronics and the board for the power electronics, and there will be a strict signaling order